Section 22 is tangent vectors and normal vectors. Suppose that you are told that the position vector is 4ti. And you're asked to find v of t, a of t, t of t, and n of t. And you also want to know the type of path the curve takes. And you also want to know if the speed is increasing or if it changes, that is, if it varies. Just remember that speed is not velocity, but the length of the velocity vector. It's the magnitude of the velocity. All right, so we have r. We can find v of t by taking the derivative of r. The derivative of this is our 4i, and that's it. And if you like, you can think of it as having also, it being the r vector, as having plus 0j, and the derivative of 0 is 0. Now, if we find the length of the velocity vector, it's just 4. Whenever you have ai plus 0j or 0i plus aj, the lengths are going to be the same. In fact, they're going to both be a. Because you have a squared plus 0 squared or 0 squared plus a squared, which is the same as a squared plus 0 squared, the square root. A squared is a squared, 0 is 0. You add them, you get a squared. And the square root of a squared, well, is actually the absolute value of a. Okay, so that's our a. The absolute value of 4 is 4. So the length of the vector is 4. That is, it's a constant. It's not changing. Remember, that's the speed vector. That's the magnitude of v. R prime is v. V of t. So the magnitude is 4. It's not changing. It's 4. What's the speed for? What's the speed for an hour from now? What's the speed for? It's a constant. It's never changing. If it was 4t, well, as t got bigger and bigger, the magnitude would get bigger and bigger. But the velocity or the speed is just 4. It's a constant. So we answered the speed question. The speed is constant. What about the path? Probably should have talked about that first. 4ti. That's x of t. That if you plug in t's, you get back x's. Plus 0j. That's y. Well, including the sign. That's y. That is, y is always 0. If y is always 0, that leaves you only one place for the points to be on the x-axis. The path is a line. As t changes, you get different values of x's. For y, as t changes, y is always 0. So the path is a line, and we answered actually 3 things already. We talked about the path being a line. We talked about the speed being constant versus varying. And we actually found v. V of t is 4i. We found v of t. Now, I'll find a of t. Now, I hope it's obvious what a of t is going to be if the velocity is constant. The velocity vector doesn't change either. It's just 4i. It never changes. The velocity, the acceleration, which measures the change in the velocity, is going to be the zero vector, 0I plus 0j. If you'd rather, you can take the derivative. The derivative of 4 is 0, and plus the derivative of 0 is 0. Okay, so we found a of t. Now, t of t, we're in a good position to just write down the answer, because that's r prime of t divided by the magnitude of r prime of t, both of which I have. R of t right here is 4i. The magnitude of r of t right here is simply 4. So it's just 1i. That is the t vector. The tangent vector, the normal tangent, the unit tangent vector is 1i. Okay. Now, so we have t of t. Now we need n prime of t. N of t. N of t by definition is t prime of t divided by the length of t prime of t. But t prime of t, since t is a constant, t prime is a constant. It's 0. It's 0i plus 0j. 1i plus 0j. The derivative of 1 is 0. The derivative of 0 is 0. And so that's a 0 vector. That's just the component vector 0, 0. That is, it starts at 0, and at 0, 0, and it finishes at 0, 0. That is, the length is 0. I mean, you want to square 0 and square that again, add them up, get 0, take the square root of 0 and get 0, fine. But nonetheless, it's undefined. So you can't talk about the normal vector if the tangent vector is a constant. A constant vector. Now let's try this one all over again with a different r of t. Suppose r of t was equal to 4t squared r. Let's talk about the path. Oh, the y value is 0 because it's plus 0j. The y value, y of t, is always 0. Y is always 0. X is 4t squared. And 4t squared is always 0 or positive. Because if you square 0, 4 times 0 squared is 0. If you square positive or negative numbers, you get positive, and you multiply it by 4, it's positive. So if t is not 0, it's positive. If t is 0, you get 0. But 4t squared is x. That is, you go along the x-axis again, but only the non-negative x-axis. That is 0 and above. 0 and above. It's a line. What's the path? It's the path of a line. Y is always equal to 0. Okay, so now let's find out r prime of t, also known as d of t. The derivative of r is 8t in the I direction. The derivative of 0 is 0 in the j direction. And there it is. So now, okay, while we're at it, let's find the length of r of t. And it's just going to be this. It's just going to be that. Okay, but that's the speed. It changes. Plug in different values for t, get different values of the speed. Remember, this is r prime. That's the magnitude of the velocity. Okay, it's 8t. It changes. T is 0, this is 0. T is 1, this is 8. T is 2, it's 16. You change t, the speed changes. The speed is a non-constant function of t. Different values of t, different values of the speed. Okay, so the path is the path of a straight line, and the speed is changing. It's varying. Okay, now we can find, so we found v of t. It's 8ti, or if you want to say 8ti plus 0j. So we found v of t. We also want to find a of t. I think I forgot to do that in the last one. Let's see if I did. It's up there. Okay, so now we want to find a of t, okay? If you take the derivative of v of t, you get a of t. The derivative of this is simply 8 on it. So we have acceleration. Now we want to find t of t and n of t. T of t is not very hard at this point, because by definition it's r prime of t, which is 8t in the I direction, divided by the length of r prime of t, which is 8t. This gives us 1i, a constant. So we have t of t. Whenever t of t isn't a real truth, it's a constant vector, then n of t is going to be undefined, because n of t is defined to be the derivative of t of t, which could be 0 for the numerator, but then you divide by that length. And that's where things fall apart, because the derivative of 1 is 0. And if you like to look at the j component, which is 0, the derivative of 0 is 0. So you have 0i plus 0j. That's the 0 vector. Its length is 0. So it is undefined. N of t, its length is undefined. Let us try a slightly different type of problem. Suppose you were told that r of t is equal to e to the t cosine t in the I direction plus e to the t times sine of t in the j direction. Suppose you were told that. And you're further told to find t of t, n of t, a sub t, a sub n at t equals pi over 2. We're going to find those 4 values. Well, to find t of t, you have to have r prime and the magnitude of r prime. So r prime of t. We take the derivative of this. The product is e to the t times something else, namely cosine t. Thing is, in the product rule, sometimes you take the derivative of the first function, and then sometimes in the other time you don't. But they're both e to the t. The first function is e to the t, and the derivative of the first function is e to the t. If you think about it, you can factor out e to the t. It's the derivative of the first function, which is e to the t, times the second function, plus the first function, e to the t, times the derivative of cosine t, which is negative sine t. That's I. Plus the derivative of this. I can factor out e to the t. It's the first function, which is right there, excuse me, the derivative of the first function, which is e to the t, times the second function, plus the first function, which is factored out, times the derivative of the second function. And there is your derivative. That's r prime of t. Now, we want to find the magnitude of this vector. We want to find the length of r prime of t. So you square the first, you get e to the 2t, times, and you square the second factor. And that will give us cosine squared t minus 2 sine t cosine of t plus sine squared of t plus e to the t squared, which I already have factored out, which I already have in the first term, so let me factor it out, times the second squared. Oh, this is in the I direction. Plus sine squared of t plus 2 sine t cosine t plus cosine squared t. And that's all in the j direction. Okay, the only thing is since we're finding the lengths, there's no i's and j's, but then we have to take the square root of the whole thing. The square root of e to the 2t is e to the t. When you have a product, I don't care if it's a little thing times a major thing, a big thing. It's the square root of the first factor times the square root of the second factor. They don't have to be the same size. The square root of ab has always been the square root of a times the square root of b. You know, what is the square root of quote b? If you take away 2 sine t cosine t, and then you add it back, that's 0. And what's remained in the first bracket is 1. Cosine squared plus sine squared is 1. What remains in the second bracket is sine squared plus cosine squared t, which is 1. Supposed to add them. So we get the square root of 2. That is, the length is 2 times e to the t. Now, I'm just going to write that result a little bit higher. So I don't forget it, I'll leave it there for a moment. I have very poor memory. It's the square root of 2 times e to the t. Now, to find t of t, we just divide those two lines. Let me put it a little bit, let me center it a little bit more. Divide that. Okay. So, excuse me. So what you get is this whole thing divided by square root of 2e to the t. So the e to the t's cancel, and you get cosine t minus sine t all over square root of 2 in the I direction plus. Now, when you do this division, the e to the t's also go, and you get sine t plus cosine t all over square root of 2. That's in the j direction. That I said from the very beginning. We don't just want t of t. We want it at pi over 2. So let me answer that right here. let me actually do it down here. T of pi over 2. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So in the numerator for the I, we just get 0 minus 1, which is negative 1 over the square root of 2. But 1 over the square root of 2, I'm going to write this way. I. Plus, in the top, we have 1 plus 0, which is 1 over the square root of 2. 1 over the square root of 2 is that. So, we have t of pi over 2, which is good. That is, this one is done. Now we want to find, actually, why don't we find a of pi over 2 as well? Let's find a of pi, let's find a of t, then we'll plug in pi over 2. A of t is the derivative of r prime. So I'm looking at the second line. And let me erase r prime of t. Let me try to erase r prime of t, maybe. There's the magnitude of r prime of t, I meant to say. So a of t is just the derivative of this. So you take the derivative of the I, then you take the derivative of the j, and you add them together. Remember, when you have e to the t times some function, and you want the derivative, you can factor out e to the t. You just do it a few times and say, oh yeah, it keeps happening. You have the derivative of the first function, is e to the t, times the second one. Cosine t minus sine t. And imagine I closed it. Plus the first function, which is e to the t times the derivative of something else. Well, I can factor out the e to the t. I can factor it out. It's always going to be able to be factored out. So you get minus the sine of t. I might have written it down wrong just a moment ago. But the derivative of the second is negative sine t minus cosine of t. That's in the I direction. Plus the derivative of this, which is just the second function, plus the derivative of the second function, plus cosine t minus sine of t. That's in the j direction. So a of t just happens to be e to the t, right there, e to the t, and this canceled out. So we're basically taking away 2 sine of t. That's in the I direction. Plus e to the t, and this canceled out. So we get cosine t plus cosine t, better known as 2 cosine t. So now a of pi over 2 is equal to e, t is pi over 2. Now the sine of pi over 2 is 1. Negative 2 times 1 is negative 2. So it's e to the pi over 2 times negative 2. I'll put the negative 2 in front. And that's in the I direction. Plus e to the t, which is pi over 2, times 2 times 0 is 0. E to the pi over 2 times 2 times 0 is just 0. So it's plus 0j. This time, okay, so I will write it. Plus 0j. And I erase t over t. Lovely. Okay. So now that we have a of pi over 2 and t of pi over 2, Now that we have those two, we can find a sub t. A sub t, by definition, a sub t of pi over 2 is just a of pi over 2 dotted with t of pi over 2. So we multiply the I values. Negative 2e to the pi over 2 times negative the square root of 2 over 2. The 2's cancel. A negative times a negative is positive, and we get square root of 2 times this e pi. We get square root of 2 times e to the pi over 2. That's in the R. That's in, okay. Plus. Now we multiply these two. But 0 times square root of 2 is 0. They add 0. You don't need to do it. So a sub t of pi over 2 is square root of 2 times e to the pi over 2. So I found that. Now we want to find n of t. Now we want to find n of t. Okay. So we need t of t. T of t is e to the t times cosine t minus sine t. That is, it's r prime of t divided by the length. And fortunately, I remember the length. It was 2. It was 2 e to the square root of 2 times e to the t. Square root of 2 times e to the t. That is, what e to the t? What are you talking about? There's no e to the t's. They cancel out. Okay. That is r prime of t divided by the length of r prime of t. That's our t of t. You know, I want to keep a of t right here. A of pi over 2. It's negative 2e to the pi over 2i plus 0j's. N of t. Let us find n of t. Okay, so I have a of pi over 2. So I could erase that down here. So I need to find, I need to find n of t. That is, first, I want t prime of t. T prime of t. The square root of 2's in the bottom, they just come along for the ride. Take the derivative of the tops. You get negative sine of t minus cosine of t over square root of 2 times I, plus the derivative of the top here is cosine of t minus sine of t. So now I have t prime. What I want to find out is the magnitude of that, the length of t prime of t as a function of t. So I square each of the, I square the I component, I square the j component, I add them up. Okay, so when you square the first one, the I component, I'm going to use shorthand notation. S for sine t and C for cosine t. So you get sine of t sine squared of t plus 2 sine t cosine t plus cosine squared t, all over the square root of 2. Plus, now you square the j component, is here. You get cosine squared minus 2 sine t cosine t plus sine squared t. And I square it, so the bottom should be 2. You square the I component, and you square the bottom, you get 2. Okay, so I have two fractions. 2's in the bottom. 2, so I have in addition, if the denominators are the same, just add the numerators and keep the common denominator. 2 sine t cosine t minus 2 sine t cosine t, that's 0. And sine squared t plus cosine squared t, that's 1. And cosine squared t plus sine squared t is 1. And I add the two ones, I get 2. And then I need to take the square root of that. And the square root of 2 over 2 is 1. Because 2 over 2 is 1, and the square root of 1 is 1. So, when I take t prime of t, and I divide it by the magnitude of t prime of t, I just get back t prime of t, which is also known as n of t. T prime divided by the length of t prime is n. It's not my fault the denominator was 1. You get what you get. Okay, so we just, oh no, we didn't answer yet another question. I was going to say that we found out what n of t was. Yes, we did, but the question said to find it at pi over 2. So what is n of pi over 2? Now you need to remember that the sine of pi over 2 is 1 and the cosine is 0. So the cosine just cancels out. It's like it's not there. And that's 1. Negative 1 over square root of 2. Negative 1 over square root of 2. The square root of 2, 1 over square root of 2 is square root of 2 over 2 times I, plus sine of pi over 2 is 1. So you have to add a negative. That's the same as taking away. You have to take away 1 over square root of 2. 1 over square root of 2 is square root of 2 over 2. And this is not in the I direction, but the J direction. So I did find n of pi over 2. Now I need to find a sub n at pi over 2. But a sub n of pi over 2, that's in the bottom right hand corner. It is negative 2e to the pi over 2 in the I direction plus 0 in the J direction. Now all I have to do is dot those two, and I will have something called a sub n. Just need to perform the dot product. That is not a sub n, that is a of pi over 2, excuse me. That's just acceleration at pi over 2. Now, a sub n at any value, say pi over 2, this is just a at that value dotted with n at that value. So first you multiply these two. I'll do that on the side. Negative square root of 2 over 2 times negative 2 e to the pi over 2. Well, a negative times a negative is positive. The 2's cancel, so you're left with square root of 2e to the pi over 2. And then when you multiply these values, since one of them is 0, you get 0. So you get the square, you just get this as the answer. Square root of 2e to the pi over 2 plus 0, which is just that. And we answered everything that they asked. The long, tedious problems. But then again, have to be able to do it. Let's do one more. Suppose you were asked to find t of t, n of t, a sub t, and a sub n for the following position vector. R of t is equal to a times the cosine of omega t, I, plus a times the sine of omega t and j. Suppose you're asked to find, suppose you're given that. And first we'll find t of t. We'll build up to that. So r of t is the constant times the function. Constant stays there. The derivative of cosine of any angle is negative, the sine of the same angle, the angle never changes, times the derivative of the angle. Since it's with respect to t, a constant times t, the derivative is just a constant. Plus a times the derivative of that. Well, this is in the I direction. The derivative of sine of any angle is the cosine of the same angle times the derivative of the angle, which is omega. Okay, so that's r prime. To find the length of r prime of t, we square this, and we square that, which is in the j direction. We add it up, square root. Well, when you square a negative, it becomes positive. You square a, you get a squared. You square omega, you get omega squared. You square that, you get sine omega squared. Plus, same game. A squared, omega squared, cosine squared of omega t. The square root of this. Now here things are going to work out nicely. What I just underlined is in both terms. So you can factor it out. And what goes inside the brackets is what I didn't underline. Namely this piece, and that piece. Sine squared omega t plus cosine squared omega t. But don't forget the square root. But this mess is 1. Sine squared of any angle plus cosine squared of the same angle is 1. And this times 1 is this. It's just a squared omega squared, which is a omega. And let me write that down higher up. It's just, oops, I have to erase it from my physical board. It's just a omega. Okay, now we divide the two, and we call that t of t. T of t is, well, you divide this by a omega, it's going to cancel. The minus does not. So you get negative sine omega t in the I direction plus, once again, the a and the omega cancel, so you get cosine omega t. That's in the j direction. And I hope it's clear. And okay, so that's t of t. So this one's done. I found t of t. Now I take the derivative. and I want to find n prime of t, which is t prime of t divided by the length of t prime of t. So t prime of t is, there's a negative, the derivative sign of any angle is the cosine of the same angle times the derivative of the angle with respect to t. Plus, I'm going to add a negative, I'm really going to be taking it away. And the derivative of cosine of any angle is negative the sine of that same angle times the derivative of the angle. Okay, so that's t prime. I want to find the length in the I direction and the j direction. So now, to find the length of t prime of t, I square this. Negative squared is positive, omega squared, cosine omega t squared, square the negative, square the omega, square the sine squared of omega t, square root, square the omega. I can factor out omega. And then what's left over is what I didn't underline. But that's 1. This is 1. I don't need it. Omega squared times 1 is omega squared. And then I take the square root of omega squared, and I get omega. So t prime of t, the magnitude, is just omega. It's just omega. Okay, so I don't want to erase that. Now, if I divide these last two lines, I get n of t. When I divide this by omega, the omega cancels out, but the negative sign does not. Minus, when I divide this by omega, the omega cancels out. Okay, so there's n of t. I found n of t. And I don't want to lose that either. I will, however, erase this up here. Now, I need a of t in order to find these two. I need to find the acceleration vector. But the acceleration vector is the derivative of r prime. And the negative a omega is there, that's a constant, times the derivative of sine of omega t, which is cosine of omega t times omega. Plus, and that's in the I direction, plus it's going to be plus a negative, which is just a negative. A omega. The derivative of the cosine omega t is negative the sine of omega t times omega. And that's in the j direction. Okay. Now, to find a sub t, that's just a dotted with t. So, I dot those two. The negative times the negative is a positive. So I get a omega squared times sine omega t times cosine omega t. Plus, now I dot those two, which actually makes a minus. So I get a omega t sine omega t cosine omega t. That subtraction is 0. A sub t is 0. Okay. Now, to find a sub n, I dot a with n. A sub n is a dotted with n. So, I take a and I dot it with n. They're both negative. Negative times a negative is a positive. I get a omega squared. And I get cosine omega t times cosine omega t, which is cosine squared omega t. Plus, now I do the same for the j components. I take a of t and I multiply it by the n of t. And they're both negative, so when I multiply I get a positive. I get a omega squared times sine omega t times sine omega t, which is sine squared omega t. If I factor out a omega squared, if I factor this out, what's left over is this plus that, which is 1. And of course, a omega squared times 1 is a omega squared. And there's the answer. And that actually finishes the section entitled Tangent Vectors and Normal Vectors. Good luck with it.